Hello everyone, I'm Mohammed Islam Shishir and this is me learning in public. So I wanted to make this video for a long time, but I didn't had the right vibe to do so. But with all your dua, I finally had the courage to start this video, and from now on I'm going to do a little bit of problem solving if you guys don't mind. And since this is my very first video, I'm going to start with the most common problem with of LeetCode, which is two sum. And yeah, so you can read through the description at your own time. Otherwise it's going to take a lot of time in this video. I'm just going to explain it briefly in this video. So this is like pretty common. Everyone probably solved this once or twice. So this problem has two variants. Let's just go to the Miro board and okay, okay. So in this problem, they're going to give us an array and a target number. So for the first variant, v1, variant 1, for the first variant, they're going to give us an array, and we have to find out if there exists in the array two numbers or two elements in the array that adds up to the target number. Okay. Okay, so for this array 6 and 8 adds up to 14. So if that's the case, if we do find two elements inside the array that adds up to the target number, we are going to return yes. And the number should be unique. We can't just add the same number with itself. So, and if we don't find any pair of elements that adds up to the target, we are going to return no. So yeah, so that's variant 1. And for variant 2, which is kind of similar, the variant 2, in the variant 2 they ensures us that there will always be a pair of elements that will add up to the target. So in this case 6 and 8, which adds up to the target 14. So we have to return the index number of these elements. So in this case the answer will be 1 and 3, which is the index number of 6 is 1 and index number of 8 is 3. So these are the two variants. Let's solve the first variant first. So let's just do a dry run, like let's just see how the thought process works behind it. So the first thing that comes to our mind to solve this problem is a brute force approach. We are going to do is that we're going to take one element and compare it to the rest of the elements. Okay. So first let's say we take 2 and we add 2 with 6. Does 2 and 6 adds up to 14? No, it doesn't. So then we take 2 and 5. Does that add up to 14? No. Then we take 2 and 8. Does that add up to 14? No. Then we take 2 and 11. Does that add up to 14? No. So after that we go to 6. Okay. Now does 6 and 2 add up to 14? No. Does 6 and 5 add up to 14? No. Does 6 and 8 add up to 14? Yeah, it does. So we found our pair that adds up to 14. So we are going to return yes. So this is the approach. This is the brute force approach. And to do that, we are going to need, let's say we have a for loop for this that starts from 0 and goes up to the end of the array. Okay, this is the first for loop. Okay, and let's say we have another for loop. Okay. Okay, so the first for loop is going to iterate through the array, and the second for loop is going to also iterate through the entire array in this case, but we're going to optimize this further later. And both of this for loop will add the elements with each other and see if they adds up to the target. So we can't just add the same element twice, so that's why we would need a condition to see if I and j are the same. We are going to continue, and let's say if array of I plus array of j equals to target, then we're going to return yes. Okay, and finally, if we never find a desired output, then we're going to return no. So let's see how this code works. So okay, so first where's the pen? Okay, first the I is at 0. Okay, this is I, and j is also at 0. So first the I is at 0 for the first for loop. It goes to the second for loop, the j is also at 0. Then it compares that it says that I and j both are at 0, so it's not going to do anything, it's going to continue. And yeah, then the second iteration of the second for loop will start. So j is going to be at 1 now. So when j is 1 and I is 0, it's not going to continue, it's going to add the two elements of I and j. So array of I is 2, array of j is 6. That is not going to be equal to 14, so it's not going to return true or yes. So it's going to go to the next iteration of j. So j is going to be at 2, it's not going to continue, it's going to add array of I, that is 2, and array of j that is 5, and it's not going to be equal to the target, so it's going to go to the next iteration of j. So still it's not going to continue since both of these are not at the same index. So array of I, which is now 2, array of j, which is now 8, so 8 and 2 is 10, so it's not going to be equal to 14, and j is going to go to the next iteration, and yeah, j is going to point to the next index. So now I is at 2, j is at 11, so array of I 2, array of j 11 will add up to 13, which is not going to be equal to 14, so it will not return yes, and this for loop ends, and I goes to the next iteration. So I is now at index 1, and j is now at index 0. So it is going to add 2 and 6. It's not going to be equal to 14, so it will go to the j will go to the next iteration. So j and I both are at 1, so it's going to continue. Then j is going to go to the next iteration, j 6 and so now the array of I is at 6, array of j is at 5, so it's not going to be equal to 14, it's not going to return yes, so j is going to go to the next iteration. And now finally I is at 6, j is at 8, so 6 and 8, array of 6, array of I is 6, array of j is 8, so 6 and 8 is equals to 14, which is our target. So now this condition will be true and it will return yes. So this is how we can solve this problem with the brute force approach. Let's just implement this and see if it works. And I equals 0, I less than n. They gave us the size of the array, so that's convenient. And I plus plus. And for the next for loop, int j equals 0, j less than n, j plus plus. And if I and j both are same, we're going to continue. If in this case the name of the array is book, so instead of arr we're going to say book of I plus book of j. If this adds up to the target, we're going to return yes. And if we never find the desired elements, we are going to return no. So I think this should work. Okay, this works. So yeah, this okay. So now how can we optimize this further? So in this case we saw that there is a case where I and j both are same. I mean when I is at 0, j is also going to be at 0. For some cases when I is at 1, j is also going to be at 1, and in those cases we were going to continue. But that is going to take some extra time. So and we do not like, what is this doing? It's comparing 2 and 6, then it's comparing 2 and 5, then 2 and 8, then 2 and 11, then it's going to 6, I is going to 6, and then it's again comparing 2 with 6 with 2, then it's going to compare 6 with 6, then it's going to compare 6 with 5. So we don't need to compare 6 with 6, or we do not need to compare 6 with 2, since on the first iteration of I we already compared 2 with 6. So we can just start we do not need to start j from the index 0. We can just simply start j from the very next iteration, next index of I. So we can say that okay, so we can say that j is going to be I plus 1, and we can skip this line. Yeah, so now it's going to so now what will happen is that I is going to be at 1 and j is going to start from I plus 1. So j is going to I is going to be at 0, I is going to be at 0, and j is going to start from I plus 1. So j is going to be starting from 1. So now we do not need to compare like each element with itself or with its previous element. So that's going to reduce the time complexity a little bit. So but still the time complexity is going to be n square, since we are using 2 for loops. In the worst case scenario, I is going to iterate through all the elements, and j is going to iterate through all the elements for each element of I. so it's going to be n, and this is going to be n, and this is happening for each element of this for loop, so it's going to be n square. The time complexity is going to be n square. And since we are not taking any extra space here, yeah, we are not using any space in memory, so the space complexity is going to be 0 for this. Okay, let's try out this approach. This is obviously going to work. All we have to do is we're going to skip this line, and we're going to start j from the next index of I plus 1. Okay, so this works. Let's do this for the second variant. I mean, let's do the brute force approach for the second variant. Okay, let's format the code. Okay, but for the second variant, we are not going to return yes or no. We are going to return the index number, and since I is the index number, I and j are the index number, so we do not need to do anything here. We just have to return I and j. And if we in C++, the syntax for array, I mean, there is no array actually, it's a vector, so we have to return it like this. And if we don't find anything, if we don't find our desired output, then we are going to return -1. So this should work for the first. Okay, oh sorry, since we do not have n here, they didn't provide the number and the length of the array, so we are going to have to get the size by ourselves. So instead of n, we're going to do nums dot size, and here we do not have books. The name of the array is nums, so we're going to do nums. Okay, I think this should work. Okay, so we solved this problem with the brute force approach. Now let's see if we can optimize this further. I mean, this is a n square solution, but if we have, I mean, if we use a map with it, we can solve it in we can optimize this actually. So am I going to okay, let's just okay, so let's say we have a mapper or a hash map, you can say, or maybe in JavaScript we call it object. So what object does is that it stores a key value pair. Okay, so what we can do here is that we can store the element and the index of the element. So let's take the pen. So we can store the element as key and the index of the element as a value inside the mapper. Okay, so at the beginning of the operation, the mapper is going to be empty, and here we are iterating through the entire array. So so what we are going to, let's just do a dry run for this. So for the first element, we are at index 0, the element is 2, and we are going to look see if we have anything in the mapper. I mean, if we have any number in the mapper that adds up to the target. Okay, So for 2, I mean the target is 14 and we are at 2, so how much do we need more? So 14 minus 2 is going to be 12. So for 2, when we are at 2, we need 12 to add up to 14. So we are going to look inside the mapper that do we have 12 inside the mapper. So currently we do not have 12 inside the mapper. So what we are going to do is that we are going to store, if we do not find our desired number inside the mapper, then we are going to store the current number and its index inside the mapper. So now we are going to store 2 as a key, and the value is going to be its index, which is 0. Okay, let's try to, okay, 2 and 0. Okay, so for the next iteration, okay, for the next iteration we are going to go to 6. So when we are at 6, we are going to see how much more do we need to add up to the target. So since the target is 14 and we have 6, we still need 14 minus 6. How much is 14 minus 6? I don't know. 6, 7, 8, 9, 10, 11, 12, 13, 8. Okay, we need 8. So 8 is not inside the mapper. So yeah, so we are going to store 6 as a key and the index of 6, 1 as a value. So then we are going to go to the next iteration, 5. So 5, how much more do we need? We need 9. So 14 minus 5 is 9. So do we have 9 inside the mapper? No. So if we do not have 9 inside the mapper, we are going to store the current index, current element and its index. So we are going to store 5 and its value, and its index 2. Okay, so currently the mapper looks ugly. Okay, so now we are going to go to the next element, which is 8, and how much more do we need to make 14? So 14 minus 8 is equals to 6. Do we have 6 inside the mapper? And it turns out that we do have 6 inside the mapper. So if that's the case, for the first variant we can return yes, and for the second variant we can return the index number of 6, which is the value of 6, and the index number of 8, which is 3. So that's how we can solve this problem with using the map of data structure. And okay, how do I erase this? Okay, so yeah, this is how we can solve this problem with O of n time complexity. But the drawback is that we are taking a mapper which is going to take extra space in our memory, and since we are going to store all the elements and their indexes, so there is going to be n elements, so that space complexity, we are going to store n elements in the mapper in the worst case, so the space complexity is going to be n. and the time complexity is also going to be n. But this problem at least gives us a faster solution. So let's just code it out. Okay, let's take let's take an unordered map which is going to have integer as key and integer as value, and let's just call it mapper. Then we should have our for loop, int I equals 0, I less than nums dot size I plus plus. So it's going to iterate through the array. And what else? Okay, so we need the number that we need to find the complement number that adds up to the number. So now let's just say complement is equals to target minus current number. So if the target is 14, in this case if the target is 14 and the current number is 6, so 14 minus 6 is going to be 8. So 14 minus 6 is 8. So that's what we are doing here. So target is 14, current number is 6, so 8 is going to be the complement. Okay, next we are going to see if the complement exists. So what we are going to do is that we are going to see if 8 exists inside the mapper. So in this case so mapper dot find complement mapper dot end. If we do find the complement inside the mapper, we are going to return the index of the complement and the current index. And if we do not find in this case there will always be a pair that is going to add up to the target, so we do not need to set anything in default. So if we do not find if we do not find 8 inside the mapper, or if we do not find the complement inside the mapper, what we are going to do is we are going to store the current indexes current elements value as the key and the current elements index as the value. So mapper of nums of I is going to be I. So this is the current element and this is the current index. So we are storing the current element as a key and the current index as a mapper, as a value. So this should work. Okay, I forgot a semicolon here, I guess. Okay, so maybe we do in C++ we do need to have a default return statement. Okay, now it's accepted. So this is how we can solve this problem with O of n complexity and O of n space complexity. I mean, the time complexity is going to be O of n, and the space complexity is going to be O of n also. Okay, so yeah, I have come this far, so I am kind of proud of myself. Now let's solve this problem in Ruby. Okay, for Ruby it's going to be a little simpler. So all we have to do is initialize a mapper, and then run a loop nums.each with index. So that is going to give us do num and index. So that is going to give us the each element with its index number. So yeah, so complement is still going to be target minus the current number, and if mapper.key complement, so if the mapper has the complemented number, it's going to return the index of the complement and the current index inside an array. And if the mapper does not have the complement, it's going to store the current number with the current index, and in this case the index is not going to be I, it's going to be index. So I think this will probably work for Ruby. Okay, so we have to, in Ruby we always have to do end. I forget this sometimes, so yeah, I think this should work. Okay, so this is the solution for Ruby. Now let's do it in Python. Okay, it's pretty much similar in Python. So in Python we also have to initialize the mapper, and then we run a for loop. So in this case for num of nums, what we are going to do is going to have the complement, get the complement is equals to target minus the current number, and we are going to see if complement is inside the mapper. If that's the case, if we do get the complement inside the mapper, we are going to return the index of the complement and the current index. And if we do not get the complement inside the mapper, we are going to store the current number with its index as key. So this should work. Okay, what's wrong here? Invalid syntax for num of, okay, maybe it's in for num in nums. Okay, in Python it's in. And what's wrong here? So we are not getting the index here, so we have to get the index manually. In Python, if we want the index of a particular array, we do this. We say enumerate. That's hard to pronounce. Okay, now it's going to give us index and number, index and the current number. So it's going to give so index. Okay, now this should work. Okay, it says okay, we have to return it. We were not returning anything. Okay. Okay, so now this works. Okay, let's solve this for JavaScript. Why am I doing this? Because I don't know, I mean, it's fun to do, I guess. And for JavaScript, let's do it like this. Const mapper is equals to mapper, I mean, let's initialize the mapper. Okay, let's do a for loop. Const index comma number of nums dot entries. So now what this does is that nums dot entries will give us each element of the array with a pair of its index and number. So now we can say const complement is equals to target minus current number, and then if complete, okay, we have to have a first bracket here, complement in mapper. If complement does exist inside the mapper, we have to return mapper of, I mean, the index of the complement and the current index inside an array. Otherwise, we're going to store the current element with its index. Okay, I think this should work. Okay, so yeah, we solved this problem. Okay, we solved this problem with two approaches, brute force approach and using a map. And sometimes people could ask you to solve this problem without using any memory. So in that case, what we can do is that we can sort this array. Okay, it's kind of like, no, it's not like the binary search approach. It's kind of like a two-pointer approach. So what we can do is that we can sort this array. So let's say we sort this array as 2, 5, 6, 8. Yeah, let's say we sort this array and we get this, and then what we can do is that, where is the pen? Okay, let's have a pointer at the left side and let's have a pointer at the right side, and add these two. So 2 plus 11 is going to be 13. So if so the sum of these two, if sum of these two is less than the target, so 14 is greater than, or maybe I can say that 13 is less than target, or 14. So if sum of these two is less than the target, then what we have to do is we need a bigger sum to match the target, right? So we are going to move the left pointer. We're going to move the left pointer, and do the sum again. So 5 plus 11, that is going to be 16. So 16 is greater than 14. So now the sum of the elements are greater than 14. So now we need to decrease. So now the sum needs to decrease. So when we need to decrease, we move the right pointer to the next index. So now, okay, so now what we will get is that 5 plus 8, 8, 9, 10, 11, 12, 13. So it's going to give us 13, 14, 13 is like less than 14. So we have to increase the sum to match the target. So now we move the left pointer to 6. Now we add the right and left pointer, so it's going to give us 8 plus 6. 8 plus 6 is going to be equal to 14, and then we can return yes. But this approach only works for the first variant. I mean, this could also work for the second variant, but it's not going to be an optimal solution. So yeah, so this is a two-pointer approach that could also solve the problem without using the extra memory or without using the mapper. So yeah, let's just see how we can do this for the first variant. Okay, let's say we have to sort the array first. So sort book dot begin and book dot end. So sorting is done. Now we initialize the left pointer as 0 and the right pointer as n-1. Then while left is less than right, we are going to loop through the array. Okay, so if book of, okay, let's just take the sum first, and sum equals book of left plus book of right. So if the sum is less than the target, if sum is less than the target, we have to increase the sum. So the left pointer, okay, first we have to look if the sum is equals to the target. If sum is equals to the target, then we got our desired output, so we return yes. Otherwise, else if sum is less than the target, we increase the sum, so left plus plus. And if sum is not less than the target and sum is not equals to the target, so sum is obviously greater than the target, so we need to decrease the sum, so right minus minus. So this should solve the problem, and we have to return something in default. Default should be no. If we never get anything equals to the target, then the white and the left and right, I mean the right and left crosses. Okay, it's going to be left, not left. So yeah, this should work. Okay, this works. So yeah, so this is how we can we can see that we have, okay, I need, okay, okay, so we solved the two sum problem in three different approaches. So yeah, there are, I think we can also solve this for the variant 2 with the two pointer approach, but that is not going to be an optimal solution. This is the best solution for the variant 2. So yeah, this is it. This was me trying to uh, learn problem solving, I guess, and hopefully I helped you refresh your memory too. So yeah, let me know if you have any suggestions for my video, or let me know if uh, what kind of problem I should solve next. So yeah, anything, any kind of positive criticism is appreciated. Thank you for all watching, and have a good day. And yeah, don't stress about it, everything is going to be okay. uh, yeah, thank you.